Yes, so we are in alcohols and alkanols. We look at the general formula. We also look at what we call the functional group and the examples. And in examples, we are considering the number of carbon atoms given and we place in the general formula. We come up with that specific alcohol. We also look at the molecular formula, and at the same time, we look at what we call the condensed formula, the structural formula, and the IUPAC name given to that specific alcohol. Now we are going to see how these alcohols or the alkanols are being prepared in the lab. So we shall have what we call the lab, or sometimes say laboratory preparation of alcohols. But now we are going to be specific here. We can say it in bracket. We have ethanol. We have seen the example, so we are going to focus on that specifically. Now, what do we know? What do we need to know about these alcohols? These alcohols, the alcoholic drinks, those we have, the alcoholic drinks, e.g., we have vodka, we have spirit, something of this kind. We have those other ones. All these ones, they contain what we call ethanols that we are going to look at. Some percentage of ethanol is there. But also these alcohols or the ethanols can be produced naturally. They can be produced naturally. But from what? They can be produced naturally from plants. And that thing happens during what we call an anaerobic respiration in plants. During anaerobic respiration in plants. So when you say anaerobic respiration, that means there is no oxygen in that process. So when we have our glucose, in this format, this one here can be broken down without oxygen to bring for us ethanol, which we write like this. You can say CH3, CH2, OH, plus some carbon dioxide being produced, plus energy. So that energy will be used by plants for other processes. So this is natural how this ethanol can be produced. But now let's look at how it can be prepared in the lab. And we're going to focus mainly on what we call the fermentation process. Now someone will be in position to ask you, what is fermentation? So fermentation is simply the decompositions of sugars by yeast, or we can put it in bracket by enzymes to form what we call ethanol. So that is fermentation. People have been using this fermentation throughout their life. Sometimes they use fermentations when they are doing local brewings of alcohols. And also this fermentation process can be used in the lab for us to get ethanol. So that is what we call fermentation, simply the decomposition of sugars by yeast or enzymes to form what we call the ethanol. Now let's look specifically at how we can prepare this one in the laboratory through fermentation. The first thing we can get is the starch itself. We know starch is a polymer. Starch is a polymer of a glucose molecules. So that means in the starch, we get what we call the glucose units. And also they become what we call the monomers. So therefore, these monomers combined form what we call the polymers. So here, this starch is pressure cooked So that means you exert it to some pressure, and then in the process, it is treated with what we call the malt at 60 degrees Celsius to produce what we call the maltose. So the equations can be written like this, and the enzyme involved in this process is what we call a diastase enzymes. So chemically, we can come up with it like this and say it. If I have my starch, which is CH6, H10, then I will have oxygen here is 5. If I have this one in presence of water, and then these enzymes here, we say diastase enzymes. We know enzymes catalyzes the process of the chemical reactions, but at the end of the day, or at the end of the reaction, they remain unchanged. So here we shall be in position to form what we call the maltose. So maltose is written in this format, shall have C12H22, then oxygen. Oxygen, we have it in that format. So here, this is the starch, of course, and what produces here is what we call the maltose. What is produced here is what we call the maltose. So someone will be in position to balance these equations by putting 2 here. So we shall have 2 times 2 shall have 12 carbon atoms this side, and also here 12. We shall have 2 times 10. We shall have 20 plus this. We shall have 22. Here we shall have also 22 hydrogen atoms. Then this times 5. We shall have 10 plus 1, 11. Then we have something like that. So here, what do you need to know here when you are revising? One, you get the starch and you treat it. Starch is pressure cooked, and then it is treated with malt at a temperature of 60 degrees Celsius in presence of diastase enzymes to get for us the maltose. Now, this maltose will undergo what we call hydrolysis. Will undergo hydrolysis to produce the glucose molecules. So how does this one go under what we call hydrolysis? You treat this one with, you can say, you come back and say, I have my maltose undergoes hydrolysis. So that means you have water molecules here. This one here happened in presence of a specific enzyme called the maltase enzymes. So this one here will undergo hydrolysis to produce for us what we call the glucose molecules. So we shall be in position to have C6, and we shall have H12, shall have oxygen 6. So when you look at this thing critically, you want to balance, you can just put 2 here and say it, I'll have 2 times 2. 2 times 6, I'll get 12. So we shall have also oxygen atom, carbon atom 12 this side. Then here we shall have 22. That means plus 2, I'll have 24. So I'll say 2 times 12, I have 24 hydrogen atoms. So what if I also look at this, the oxygen, hydrogen atom? How about if I look at oxygen atom and say 2 times 6, I'll be in position to get 12. Then here, I'll have 11 plus 1, shall have 12. So the whole of this reaction take place at what we call the room temperature. So you can place your container at room temperature so that the reaction will take place. So now, here for us to produce ethanol, we shall be in position to say it, that the ethanol produced, the glucose produced is then treated. We're still in glucose. The glucose produced, CH3, CH12OH, O6. This one here is treated with specific enzymes called zymase enzymes. So these zymase enzymes will be in position to catalyze the decomposition of glucose to bring for us what we call the ethanol, CH2H5 and the OH. So when we look at this thing critically, we're saying that, yeah, some gas is being formed here, which is carbon dioxide. So let's balance the equations. We shall be in position to put our 2 here and say it 2 times 2. We shall have 4 carbon atoms, yet here we have 6. So that means I will increase the mole of this one by 2. Then I will say it 2 carbon atoms plus 4 carbon atoms, I will have 6. So that means carbon is done. Then we come to hydrogen, we shall have 12. About here, we shall have this plus this is 6. So we shall say 2 times 6. We shall have 12 hydrogen atoms. Then oxygen 6. So let's come here and say I have this 2 times this one. Oxygen, you shall have 2 moles of oxygen. Then this time this we shall have 4 plus 2, we shall be in position to get 6. So that means you have produced your ethanols in the lab through the process of fermentations. Now, what you have produced here is what we call the crude ethanol. That means it is impure head. So for us to make it pure, we can look for a process called fractional distillation. So in fractional distillation, we shall be in position to produce 95% ethanol. So that means it is now pure. And then the 5% will be, of course, water. So in the process, you have produced your ethanol in the lab through the process of fermentation. Just very simple like that. What you need to take good care of is that the equation should be in position to balance the equations, and you'll be in position to know that what enzyme is used at a specific step for us to reach to the point of producing ethanol. So sometimes in exams, they can say using equation only, describe how ethanol can be produced the lab through the process of fermentation. So you'll be in position to come up with this equation well balanced. You'll be in position to come up with this equation well balanced with the enzymes you're showing the reaction. Then you'll be in position to come with the third equation, and you get all the marks. What if they say using wax describes, or just the equation is just open, describe the process of production of ethanol in the lab through the process of fermentation. You'll be in position to tell us the words, and then after that the equation, write the equation like that.